You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. This week, I spent catching up and preparing for upcoming events and activities after an amazing Devnexus conference last week. I will fill you in on some of the highlights from my perspective on that event. Then I also knocked out a few smaller items that I have been wanting to work on for a while now, so I blocked some time to accomplish those. To close us out, I came across an unusual approach to AI applications that has sparked my curiosity and some thoughts. Stay tuned to hear more about what I uncovered. To start us off, though, I wanted to talk about the Devnexus conference that was last week in Atlanta, Georgia. This was a very busy event for me this year, but I really enjoyed it and had a ton of fun. I had 2 sessions that I gave this year. Both went very, very well. It was great to interact with people. I had a co-presenter for one of them, and it just ended up being a ton of fun. I am always a little bit nervous, especially with new content, and both of these sessions were pretty much new. I'll talk a little bit more about that in a second, but I was very well prepped and I was super excited to give them and get feedback on that. I reviewed and prepped between each one of my sessions, so both sessions were in the same day, which was a little bit overwhelming at first, but I did have some time in between to prep the next thing. That just really meant that I didn't have a lot of time to do anything else that day, which was kind of a bummer because it was day 1 of the conference. So unfortunately, I missed the keynote and I missed a bunch of other sessions as well, but most of the sessions were recorded, so I'm hoping to catch a lot of the recordings when they come out here in a while. My solo session was the first one that I had for the day, and that one was Agents, Tools, and MCP Oh My, Next Level AI Concepts for Developers. In previous podcast episodes, I had mentioned that I had given one of these sessions before, this one actually, the solo session, and I wanted to redesign some of the things. Some things just didn't feel like they were quite clicking into place for me. I didn't feel smooth and comfortable about the storyline, the narrative, the intrigue, how things flowed. And then I got some feedback kind of along those same lines as well. So I really wanted to take a step back and see if I could improve this. And so I went into building this session for Devnexus with a totally fresh mindset and reapproached a lot of different things and redesigned most of the presentation, actually. My goal for the session was to break down these individual pieces that I think it's so easy for us as developers, especially those of us who have been in the space for a while, to talk about these really complex AI topics and forget that these are all building blocks. And I wanted to break down those pieces and show how the building blocks could be customized and built up into whatever stack might be most beneficial for a use case or a particular project or a particular developer's interests. So that was my goal, to take a tech stack. Of course, I had a particular tech stack that I was coming to the table with, but any of these pieces could be swapped out and replaced. Someone could pick up the pieces and go, well, I want this piece, but I don't want that piece. And I need this in my application, but I don't need that, and be able to customize it as needed. I started off with AI feels a little bit magical, but when you actually try to plug it into something, then it becomes really complex and difficult very quickly. The step that a lot of people go to is agents. What are agents? How do they work? I go into a little bit of agents and how you work with agents, how tool calls work, how that operates within the general tech industry right now. Then we talk a little bit about how you have to really focus your context down to pull the most valuable things for the large language model. Large language models are really good at a lot of things, but they don't handle a ton of information all at once very well, which honestly humans don't either. We have to pick and choose the bits of context that are most important. And actually that really comes back and into play when I talk about my next session here in a bit. But in this session, we talk a little bit about how you have to design your retrieval, talk very briefly about AI memory and chat memory, long-term and short-term memory. And I demo that really quickly. And then I talk about how agents do run into some roadblocks and MCP solves some of those things. Talk about what MCP is, how it works, how the architecture, how it gets put into applications, and then also demo that as well. And then show that AI systems really aren't just about the large language model. There's so much more at play, and we as developers have a very important part to play in that. And of course, code and resources at the end, which I will also share in the show notes. Then the second presentation that I did was a joint session with Aaron Schnabel and we talked about supercharging applications with Java, graphs, and a touch of AI. This one was a ton of fun. I learned so much through this exercise of putting together the application that I did with her, and we really came out with an unusual approach to presentations. Normally, my presentations are buttoned up. I rehearse them well. I walk through all the examples and make sure everything worked very smoothly. And this application was much more about lessons learned. What did we learn through this? Where were the gaps, the pitfalls, the things that didn't go so well, and then other things that actually did go very well? So we showcase both the positives and the negatives a little bit more in this session, and I really enjoyed that very candid exposure to what was going on and how we actually put this application together, or I guess multiple applications in our case. We wanted to go beyond the chatbot, and what we really wanted to do was create a role-playing game using a large language model as the other player or dungeon master. So basically, the large language model should be leading the game and the storyline and the narrative. And then the player, the user, us, would be able to interact with that and help guide or interact with the story. But the large language model was supposed to be driving it. So we used LangChain4j, Quarkus, and Neo4j, all really cool technologies, things that we found some gaps, some strengths, and some fun things along the way. We talked a little bit about a couple of different approaches. We picked 2 different role-playing games in the end. There are a couple of different versions of a Dungeons and Dragons offshoot that we picked. And we ended up going with a couple of different approaches here because one approach wasn't working the way we thought it would. And so we started with another approach to see how that worked, and totally different tech stack in the end, but very cool results and a lot of things that we learned through that. We interact just first with a plain chat. What does the large language model already know about these particular games? Which, of course, it had a lot of knowledge for one game, actually, but not very much knowledge for another game, because a lot of the lore and backstories and things aren't as widespread and common. Therefore, it's harder for the large language model to pick that out of its training data when it tries to search through those patterns. So we talk a little bit about plain chat. What does the large language model just know out of the box? And then, okay, what if we could maybe just write a decent prompt, and would that guide it enough to give it enough information? And it actually was for one of the games. That worked really, really well, just constructing a nice prompt. The one where the game that the LLM knew more about, we were able to construct a good prompt, and then it was able to retrieve enough from its patterns, from its training data set, that it could answer a lot of the questions, which was really nice. Simple, very effective, easy win out of the gate. Now, with the other game, we needed something a little bit better, right? We couldn't just prompt our way into it. Therefore, we looked at retrieval augmented generation. And we picked Neo4j as the data source because we could tie a lot of the chunks of backstory and lore together inside the graph. For instance, you have these very large documents about characters and creatures and how games are played and rules and all sorts of other things. And we're able to chunk those up, but then keep the overall document structure because we can chain them together in a graph database. So that's exactly what we did. We ingested the data. Some of it is chunked up and connected. Some of it is just separate chunks, almost like a vector store. We're able to put both those different approaches combined into the graph, which worked really nicely. Then we talked about how the retrieval piece works. So once we split up, chunk up, save it, embed it inside the database, then we need to actually retrieve that back out. And we do that in a couple of different ways. Now, because we have some of these chains of the different chunks within the document, so larger chunks within a bigger document itself, then we could also grab, hey, here's the most relevant chunk when we do our semantic search, but I'm also going to grab the previous chunk and the next chunk alongside that as well. This was really nice because you could grab a somewhat larger segment if you needed to based on what was surrounding that particular chunk that came back. And then we started working on some tool calling, figuring out how to create tools for calling different things. That worked pretty well for at least lore chat and trying to pull back retrieval augmented generation based on questions about the game. But that didn't really work so well when you actually tried to interact with the large language model and work through a game. There were a lot of challenges there. We ended up with 3 C's: continuity, the storyline that you needed to navigate while you're playing this game, It's creating the story, remember, for this role-playing game. Trying to have it maintain the same storyline and follow with the same characters and the same general settings was really, really hard. Then context. As you might imagine, as you continue to play the game, the context gets bigger and bigger and bigger. That gets really hard for the large language model to sift through. And then it's really hard to get it to be creative, but not so creative that it's hopping all over the place and doing random things that don't make any sense in the context of the story. So those were the 3 C's that we had challenges with: continuity, context, and creativity. We found out that the gameplay segment was really a lot to ask of a large language model. It just couldn't keep track of everything. It was blowing out the context in a lot of cases. And the local model that we had chosen just really wasn't designed well for reasoning and tool calling. So we switched it up a little bit. We changed the model. And then we also separated some of the concerns out. We had the large language model drive part of it, but then we had an engine, which was a very technical developer hands-on concept inside the application that would handle some of the other things. LLM handled some tasks. The engine part of the application handled some other things. That worked really, really well. It separated some things out, took some of the load off the large language model. And we were able to do that across the board. We were able to do that inside character creation segments and inside the gameplay itself and in other places of the application. Now, this was starting to get a little frustrating though, because even gameplay there wasn't doing as well as we had hoped. So we switched gears a little bit. My colleague took an approach of one of the other games that was working better with just the interactive vanilla chat, and some of the prompt engineered focus of chat was working well because the large language model was already trained on that. But totally switched directions here and went with a memory storage using a markdown file, which is a somewhat common approach right now. You either use a text file or markdown file to keep track of your chat memory, if you will, or the agentic memory. This also meant we could go in, we could tweak and edit as we needed to. If something failed, we could erase that turn in the markdown file and have it start back at a previous turn. Or if we didn't like where the game was going, you could do the same thing there. This helped balance the continuity and the context window limit. So this improved some things. Now, it also was doing some incremental indexing. We didn't ingest the retrieval augmented generation stuff up front. We actually let it auto index as you were creating the game. Now, this game works a little bit differently. It's much more player driven. So the player acts as the story narrative driver, and then the large language model just acts as another party. In this case, we couldn't really store anything during the gameplay until the player actually started creating the story as you play. So with this, it got stored, and then you were able to retrieve relevant memories as you went along the way. But you weren't storing anything until you were actually playing and live interacting with the large language model in the game. This would all get added. It would get incrementally indexed at the time that you would type those messages, and then of course get retrieved as needed. That worked really well. So 2 different flavors of this. We had 2 different applications, and Neo4j handled both of them. We had a Neo4j instance backing both these segments. We were dropping the gameplay stuff for one game into Neo4j. And then on the other side, we had the retrieval augmented generation and the gameplay things going into Neo4j as well. So this was really fun to look at 2 totally different approaches to role-playing games using the same database as the backend. However, this wasn't all. While my colleague was working on that approach, I switched and went back to the original application and just really felt like we were missing something. And so I redesigned the app with an agentic approach. Let's see if we can turn this into the gameplay as agents. That offloaded even more of the large language model's workload, and it also pulled a little bit more determinism back into the system, because now I'm able to segment out, put each one of these functions that the large language model was handling before, I'm able to put them inside tools and let the agent figure out which tools it needs to call, which things seem most relevant for whatever the gameplay is doing at that point in time. So had a new app architecture. One thing that was really cool about this is I had an agent that would do a dice roll. I had an agent that would do some narration pieces. And then I had 3 separate agents, one for suggested moves that you might want to make, one for checkpoints. So whenever you reach a particular point inside the game, kind of like video games, and you might get saves every so often at checkpoints, kind of doing that during this game. And then also a recap agent. So if you stopped for a while and came back to it, or if you needed to recap a previous event or something, it would save those. Now, the last 3 that I mentioned, the suggestion agent, the checkpoint agent, and the recap agent, all could run simultaneously. So this was concurrent agents. Now, the others relied on some context from other pieces, so I wasn't able to do those concurrently, but those 3 steps could run concurrently all at the same time, which sped up the process a lot more. Then we demoed all of this. We showed each of these pieces along the way and found some lessons learned through all of this that we talked about throughout the presentation, as well as recapped those at the end. Now, we're still not done. There's still a lot of work we want to do on this to improve some of the things. Gameplay is still not flawless. We want to fix some things with both applications to make them more performant, more interesting, still help the continuity over time. But this was a way better outcome than we originally were thinking was going to end up happening. Of course, code and slide decks and all of that will be available for these sessions. Okay, back to our regular scheduled program here. In between my sessions, I hung around the Neo4j booth. Neo4j showed up in force this year at Devnexus, which was a lot of fun getting to see a lot of people that I know at the event, plus several of my team members as well. I got to talk to a lot of different people, and we were doing some Fika AI interviews where we talk about what was going on in the space, the projects they were working on, etc. I also recorded a session for another event there as well, so that kept me busy. Overall, this was a ton of fun. I had some great interactions, lots of curious people, and high excitement. This is one of my favorite events every year, and this year definitely did not disappoint. After I got home, which is usually the case, I realized just how valuable and how much of a whirlwind the week was. Okay, other things that I worked on this week. It was a little bit of a quieter week, which was nice because then I got to pick up some other things that I hadn't gotten to do in a while. The first was one of my colleagues mentioned to me that every time they would follow a link to my podcast, it would take them to their app store. But that's not really helpful, right? You have to download a whole separate thing, or you have to go out to a website. Maybe if you're working on a mobile device, as I often do, I don't really want to do that. I don't want to add another app. I don't want to go out to another web page and do something else. I want to listen to it in whatever application I'm already listening to podcasts. I had to do quite a bit of research to find a non-Podbean approach. My podcast is published through Podbean. I did finally find a way to do it, but I had to claim my podcast on Podfollow, and then I was able to create a platform agnostic link for the show itself, the overall show, and as well as each episode. So I will be doing that from here on out. If you didn't see my social post this week, I did share the episode that I had a couple of weeks ago. I pushed that out on Podfollow and was able to share that on social. This episode will also have a Podfollow link, which will send you to whatever podcasting app you lean towards on your device. I really was excited to get to publish a new blog post on some recent things that I learned with the Cypher AI procedures. I don't have as much time to tech blog, but I really enjoyed spending the time to put this blog post together. If you enjoy reading tech blogs, feel free to check out my website, jmatrife.com/blog, and you will see that post there. The content piece that I was able to read this week is called No Keys, No-LLM, Building a Wikidata Definition API with Embabel. I found this article really, really interesting. And as I walk through it, I'll talk a little bit more about this. First of all, here are the components that were involved in the application. There's a no operation model. They used some dummy model configuration in the app just as a placeholder, basically. There's no large language model being used for this application. What, you might say, an AI and agentic application without a large language model? Yes, I found this kind of unusual and really interesting as well. The author used Embabel, which is a Java framework that is used for AI applications, as the planner and executor. It's an agentic framework, and it handles the planning and execution of your agentic system. So the author was using Embabel to handle this piece, but again, no external LLM, no local LLM either, just using whatever's in the agentic framework of Embabel itself. The application has a few different dependencies, and the author steps through a few different alterations that they made in that dependency section as well. The Java records become your input and output types. One thing about Embabel is it's more structured in the input and output that it provides. It often deals in records or in JSON or some other type of structured format. Then there's a repository in the application for some data access, and then the Embabel agent, which defines the workflow and the goal. There's also a service to invoke the workflow and a controller to expose an endpoint to interact with it. The author then walks through a demo where they call the endpoint, they show the response, which returns an object as JSON. And then the interesting part, which is the logs, actually, where you can see the agentic system in action. You see its process and Babel's agentic process that takes different steps and achieves the goal that's needed in this. This post is a starter application that claims to showcase what Babel is and how it operates in a sample application. The author does offer some ways that it could be extensible and mentions some pathways in order to do that. So if you were interested in extending this or looking into this further, and maybe the author will extend in some of these different ways as well, it would be really cool to see. I am really curious to see if this type of no-LLM agentic application pattern might be used more broadly, or if this is simply just a random one-off experiment. It will be interesting to see where this goes. Coming back from Devnexus, I was able to evaluate how exciting and busy the event truly was. I felt like my sessions went really well and helped others understand some of the things that I have learned. This week also allowed me to work on a few things I haven't gotten to in a while, like write a tech blog post and fix my podcast link to be platform agnostic. Finally, I got to read an article writing an agentic application without an LLM and used Babel as the agentic planner and taskmaster. Thanks for listening and happy coding.